All right, let's take a look at what some of our products are going to look like. So we're going to form an alkene. In general, the rule of thumb is that mono, di, and tri substituted alkenes are okay. The tetra substituted, not so much. It's not that you can't make them, it's just more hard. And the reason for that is the sterics. And especially with the transition state of the Wittig reaction, which we won't take a look at, but sterics do kind of play a major role. When we're talking about our di and tri substitute alkene, we can think about where our substituents are going to go. And in general, Z is favored. So you can think about, what Z means. Z, remember, is we're talking about whether our alkene, our main substituents are on the same side or opposite side. So on Z, they're on the same or same side. If we did E, they would be on opposite sides. So something like that. So Z is generally favored for our simple molecules. There's an exception, of course, because it's organic chemistry. And the exceptions are when we have our ylid is attached to some kind of electron withdrawing group, or when the ylid is attached to another benzene ring. When we have these, E will be favored. And that has to do with the transition state of this reaction, which we're not going to take a look at too much because it's a bit beyond the scope of the course. But overall, you can imagine this is a very powerful reaction. So for example, if you had this aldehyde, you could add this ylid. And in this case, I've drawn an electron withdrawing group. So you can think about the stereochemistry there. We're going to end up with E. Or if you want to think about it as trans, that's fine too. Whereas normally they'd be Z or cis. Really take a look at the work along for examples. And another really powerful thing about the Wittig reaction is, of course, we can make our carbon-carbon bonds, right? So for example, if we've got that aldehyde and this ylid, we'll form our product over here. Right, where this part comes from this part right there, and then this comes from the ylid. And note that it's in a Z configuration. And then, of course, if we wanted to reduce our alkene here, we could just add some H2 and some platinum, and then we can form an alkane. So you can see how we can make huge molecules relatively easily.